Hello, everyone. Welcome to episode 49 of the Day Zero podcast. Apologies for this episode not being live streamed. There was, an emergency that popped up right before we started streaming today, or didn't start streaming today, rather. So, this won't affect when the episode goes live on YouTube and on like Anchor and stuff like that. It's just this one isn't being live streamed. We will be back to live streaming them again at 3 p.m. Eastern, 12 p.m. Pacific next Monday. So, this episode is packed with a bunch of various exploits, including some that you've almost certainly heard of one way or another, notably BleedingTooth and Bad Neighbor. Lots of binary-based ones too in general, though, which we love. As always, we'll start off with some news first. So Microsoft and Edge is launching a vulnerability research initiative, which means we'll be getting public research posts and vulnerability write-ups from the Edge team within a couple months' time. So in the blog post, they go into some background about Edge when it comes to security, as well as the major changes it's gone through. So for people not familiar with Edge, it used to run its own JavaScript engine called Chakra. It's since moved to Chromium, so this led to the moniker Edgium for the new version of Edge. And they've talked about how much that benefits Edge in terms of security. You know, kind of using something that's already been established and already has people managing it and looking at it, whereas Chakra was kind of the new kid on the block that had a lot of issues that people weren't really looking at as much. One thing Microsoft likes to see where they stand when it comes to Edge is pwn to own. They use that as like a security metric. So if they get popped a lot in pwn to own, for example, they take that as a need for improvement. So they point to that a little bit here and say how they found I think they said a 93% decrease in the number of reports since they've switched from Chakra to Chromium.
Yeah, they do, and I do find their language there a little bit interesting, just because they do say it's a 93% decrease in externally found reports compared to Legacy Edge. Which kind of makes me question, okay, so is that... It's just kind of hinting towards their internal abilities, and I'm curious if their internal findings have also dropped. Just because they're very specific with it being a decrease in externally found reports. I don't know if you found that language odd, but I did.
I think it's just because they want to separate it out because I don't think you can really compare the external reports with the internal reports. They're probably finding stuff internally and fixing them all the time. I think the external reports, though, are what they care about a lot more when it comes to their public security stance, I guess.
Sure,
Would be a way of putting it.
but it just kind of comes down to like what impact did switching over to Chromium have on their ability to find issues, period. Not just the external reports. Like, I do think that's kind of an interesting stat that I'd be curious to know. Like, sure, they're probably finding plenty. Obviously, they're Microsoft. They're able to throw a lot of both manpower and just CPU power in terms of fuzzing at doing that, at looking for issues there. I'd just be curious if they were finding less or more.
Yeah, I mean, that's fair. One thing I was kind of thinking about when I read that was I feel like there is a bit of a bias there, mostly because Chromium bugs are worth a lot more than Edge bugs or Chakra Core bugs would be because of Android, right? So, when you're selling to things like Pwn to Own, people don't typically want to burn their best bugs at Pwn to Own. So I just wonder if they received more reports on Chakra because it was a less financially interesting target, so that they just threw things at Chakra for Pwn to Own. And then when they switched to Chromium, it's like, oh, okay, we're just not going to look at Edge anymore at all. I feel like that's a possibility
Well,
that they didn't really mention there.
in fairness, the 93% decrease is just, with externally found reports. It's not specific to Pwn to Own. They mention Pwn to Own in the sense of our browser remained untouched in Pwn to Own, and I do think the fact that it's Chromium based could be why it remained untouched, because I mean, if they had a Chromium issue, they're going to, send it against that. They're not going to use it against Edge.
Yeah, exactly. So, I mean, I agree. I just think there is a little bit of a bias there to keep in mind. Um, What I think is most important, though, is the "over the next few months" quote, which is in the last paragraph. Basically, what they're saying is over the next few months, they're going to detail vulnerabilities they found in Edge, as well as the methods they use to identify those issues and whatnot. So I think that's that's something to look forward to. Um, Now, I will say this is more of a research initiative from the Edge team at Microsoft. It is not a vulnerability research program in the sense of like a bug bounty. Bug bounty, Microsoft's already had a bug bounty for Edge for a while. I think they launched it in August of last year or something like that. And then they updated it again in January of this year. So they've had an Edge bounty program for a while. This is more of, an internal team sharing their findings in public. That's basically what they're announcing here.
Yeah, and I'm kind of looking forward to seeing some of their write-ups. They only really have one other post besides their announcement, which is the iOS Chromium overlooked and underappreciated, where they kind of give just a little bit of an overview of like some of the IPC, some of the details about Blink being used over there. Oh, but I mean, it's fairly well done. It's kind of clear content, so it kind of leaves me hopeful that, perhaps we'll see some Project Zero type reports coming out of Edge VR. Obviously, they're going to be focused purely on, well, they not purely on, but largely on the Edge browser. But I mean, if this is anything to go on, it looks like there should be good quality content out of them.
Yeah. Yeah, it'll be awesome to look out for. And we'll definitely bring up those posts on the podcast when they do eventually arrive. So, we've been talking about Chrome. So, Chrome, or Google rather, put out an article about Chrome and HTTP cache partitioning, which dropped with Chrome 76. This post is a little bit old. I think it dropped on October 7th. But we still wanted to talk about it just because we didn't cover it before, obviously, and we've talked about cross-site leaks in the past. So they go into some background here about how their caching works, notably when it comes to how resource URLs are used as cache keys. So, if that URL key exists in the cache, it'll use that cached entry. But the problem comes in when you look at it from a security angle, right, with the leaking side of it. So, attackers using the cache to see or infer browsing history, detecting if a string is in search results using cache, cross-site tracking, which has been an issue that's been growing in concern over the last few years. So that's where cache partitioning comes into play. Basically, it seems now they're going to be using tuples for cache keys. Instead of just the URL, they're going to be using multiple parts of the URL. So if you have like an iframe, for example, the host URL that's above the iframe is added into the cache key. That way, if that same iframe is loaded from another host URL, it's refetched from the network, not from the cache. So that kind of prevents that cache side channel ability. I think it's a smart idea that probably should have been implemented sooner. At least from what I can tell, I don't know if you disagree, Z, but I don't think the drawbacks or performance impact are going to be super considerable here.
I'm unsure about that. So for quite a while, I mean, using like a content delivery network and using like a JavaScript library out of there has been a common practice to, get your jQuery from Cloudflare or something. Just because there's a pretty good chance that uh, if you're using it, other websites are using it, and there's just a good chance that your random user may already have it cached. That said, I mean, it could push things towards just having smaller packages. It's not going to impact like edge caching, so like it's still going to be kind of on the edge node of your users. So I mean, it's the performance impact. Yeah, I'd kind of agree. Probably isn't going to be as huge as some people might like you to think it will be. And I will mention that this did just land in Chrome 87 beta on, I want to say, I'm sorry, I don't have this pull up here, but they're saying that as of version 85, this landed in Chrome. I believe this is specifically for the beta on Chrome Android. But yeah, one of the reasons I did want to bring it up is because it is still relatively recent, and we've talked about the excess leaks. So this basically kills them.
Do you think it's a good move overall?
Yeah, I do. I think this is something like I do agree with you that probably should have been done sooner. If I had to make a guess, Google probably, has used this for tracking. So now that they're more established, they can just get rid of it.
They have
Like,
other methods of telemetry available.
yeah, that's kind of why I would guess they haven't done that sooner. But
Yeah.
that's purely speculation on my part. Like, I have no evidence to support that.
Yeah. So moving to some research. So we have a research paper around Magma, which is a ground truth fuzzing benchmark. So this paper is a little bit old. It's from early September. That being said, it's still yet to be presented at the Sigmetrics conference. Z also mentioned it in our recent fuzzing benchmark based topics. I think it was
Yeah, it
episode
was
48 with Unifuzz.
yeah, it was last episode. When we were
Yeah.
talking about Unifuzz, I had mentioned that I had heard about a paper, but I wasn't sure if they were joking just because of the name being like, because there's already Lava M, so coming out with Magma and Response, so it kind of working in a slightly similar but different way. Like, I could understand if people were just making a joke and I couldn't find the paper, but over this last week, I did manage to find the paper. It was just published on September 3rd, so in the grand scheme of things, it's not that old.
So it is quite similar to Unifuzz, but with a different target selection and set of metric proposals. So they tested their Magma setup against 6 popular mutation-based fuzzers, a lot of AFL-based ones. So they had AFL, AFL Fast, AFL++, FairFuzz, MOpt AFL, and HongFuzz. And they start off by pointing out why Magma is necessary in their opinion, and why current benchmarking techniques are flawed. So current benchmarking techniques being like bug findings and code coverage. Um, so they point out how crash count can be inflated due to hitting the same bug um, or just even having like drops to test machines. Those can count as crashes as well. And bug counts being difficult to assess because automated triaging is hard to assess as well. So when is a bug unique, or is it just a derivative of another bug? These kinds of issues, pointing out to why just a raw bug count might not be the best for benchmarking fuzzing.
Yeah, there's also just the unknown aspect of it. Like when it comes to bug count or crash count, like especially with crash count, they're trying to capture the fact that we don't know how many bugs are actually in a piece of software. Like there's an unknown number of them.
Yeah.
So they're trying to. That's kind of why doing crash counting was a metric, and the bug count being, did I find the known bugs? So like it does make sense. One thing I do appreciate about this paper, especially compared with Unifuzz, is that they've kind of taken the time to lay out the argumentation behind like why they've chosen certain metrics. One of the issues that we brought up during Unifuzz was just the fact that in some cases, like they made assumptions that we didn't necessarily agree with, and they didn't really lay out why they felt those assumptions were true. Whereas I feel like in this paper, they've spent a lot more time kind of making the argument for Magma, and kind of the high level overview here. With Magma, they're basically forward porting past bugs into the current version. In addition to some instrumentation to tell when a fuzzer's actually hit it. And so they're effectively bringing in old bugs back to the modern version so the fuzzer can find them. That way the fuzzers need to find real bugs using actual issues that have been found. They're selecting their bugs based off of they selected their targets based off the diversity of bugs being found. And that's one of their kind of priorities that they focus on, is the diversity. They want it to be verifiable, being one of the other things. So they know how many bugs are there, they can verify. Like basically, as they use in the title, they're the ground truth. There's some kind of standard for what's true, what should be found, what can be found. And then one of their other requirements is just keeping it kind of easy to use, easy to integrate. So it's just the binaries. There's not a lot of extra work to actually use your fuzzer against these. That said, it is, as I mentioned, they're reintroducing older bugs back into the software.
Which I believe Unifuzz did as well, if I remember right? I think they had like a set of target software that they had
Unifuzz, so you might be thinking of Lava M. Lava M would automatically inject vulnerabilities. Unifuzz was maybe I should have prepared better by reading up on or reminding myself what we talked about
Did they
last week.
manually introduce the bugs? I'm trying to remember.
I don't
thought
remember
they used Endays,
Unifuzz
but
introducing bugs at all.
okay, maybe
Like,
I'm
I
just
remember
misremembering
them choosing 20. Yeah, so they chose 20 real world projects. They included Lava M, but it was still just quantity of unique bugs, the quantity of bugs. So yeah, they were doing that automatic triaging to kind of figure out how to try and figure out the quality of the bugs. They weren't introducing any bugs though. They did use Lava M, as I've already mentioned. So Lava M, if you're not familiar, introduces some artificial vulnerabilities into the application. In particular, it adds like a if and then a 4-byte magic value that the fuzzer has to set correctly, and then it'll trigger the bug. So it's basically, in my opinion, it's kind of just testing whether or not the fuzzer can guess those values correctly. Which, I mean, there's a benefit to that metric. I just don't think it's that great.
it's not realistic. It's very artificial, which doesn't necessarily translate.
It is easily done automatically. So yeah, with Unifuzz though, I mean, they were kind of setting some things like the quality of bugs. I remember our discussion last episode ended up focusing a lot on this, or at least partially on like the stability of finding bugs and how it was able to find the same bugs over and over, the standard deviation between runs, and how many crashes and bugs it found. But yeah, it doesn't inject any bugs. So this is kind of approaching a different area than Unifuzz, in that this is kind of creating the binaries that you can then use to benchmark your fuzzer against, rather than trying to be kind of a much wider thing that Unifuzz, I think, tried to be. Anyway, coming back onto this though, it is worth noting that all the Magma bugs do need to be manually introduced. It takes human effort. That, I think, kind of feels like the killer problem for me. It doesn't scale, so how long are they going to maintain this for? And keep them updated. I do think kind of older binaries can still be valid for fuzzing and for doing the benchmark, but like once it falls into no longer being maintained, it's just kind of done. Like there's no continuous run of this or anything.
Yeah, and you're limited to the targets they chose. So some of the targets they chose, they actually provided justification here too, which I think Unifuzz lacked a little bit on. But their justification for the targets they chose were just, choosing based on the types of instructions they use, the complexity overall of the binary, what libraries they use, stuff like that. So they had libpng, libtiff, OpenSSL, PHP, SQLite, and libxml. So, a lot of parsing based libraries, but also a few other, like PHP is kind of an outlier in there too, which could be used for benchmarking, like browser based fuzzing in a way. So
yeah,
there are a variety of targets.
I'll say that, yeah, it's a variety of targets, and I think they're all valid targets. Like I don't feel like these are things that you're really just not going to gain anything by fuzzing.
Thankfully they're not fuzzing GCC like a lot of the other fuzzing papers we've covered have.
Yeah, it's not like that. So I feel like it's a fair selection. They give their justification. There are cases where you can imagine this isn't the right setup. Like, I mean, with some fuzzing, you're not just wanting to compare against the general purpose fuzzer, and that's fair. They're not trying to be your benchmark for that. They've kind of set their goal. I don't generally disagree with like any of the choices there. I think especially PHP, SQLite, and the image parsers absolutely make sense to be fuzzing. So I mean, it's just kind of tying back to the issue I mentioned before is, the human aspect of this, I think, just it makes it difficult unless this is going to be community maintained, and maybe it will be. I would love to see this actually, well adopted, and in which case, we might see this for a long time. Which is, if it's not, it's a bit of a gamble.
And unfortunately, it does probably fall on that side of it not being maintained, just because fuzzing is a little bit niche, especially when it comes to like open source and stuff like that. So we'll see, I guess.
Oh no,
But
if something,
I don't think it will be, but really by the open source community.
oh no, if something like Fuzzbench adopted it, then suddenly it could be getting used by like community maintenance and stuff.
That's a fair
Like
point.
there's
Fuzzbench.
absolutely ways it could be. I could absolutely see it getting adopted. So, and I would recommend, like, from other benchmarks that we've looked at and from the issues we've raised, looking at kind of the weird benchmarks that other fuzzers have chosen, I would much prefer to see them using this, because it does give kind of that static ground truth on how much progress the fuzzer is actually making. It gives you kind of something a bit more concrete.
Yeah, their justifications here are very solid. There were a few other points that I found kind of interesting. One of their main, goals or points of the paper is just because a bug is reachable doesn't mean it'll be found, and just because a bug is triggerable doesn't mean it's detectable. So that's kind of, going back to what they were saying with crashes and code coverage not being great metrics, right? Just because you can reach the area of code that contains a bug, you know, for whatever reason, it might not be very easy to trigger. So their primary metric here is time to bug, is what they call it. Both time taken to reach it and time taken to trigger it. There's some conclusions in there on fuzzers they tested based on Magma, which we won't go over here, but they may be of interest to some of you. Long story short, they found that Hong Fuzz had the best measurements all around, and Fair Fuzz was the worst, and the AFL ones kind of fell in between there. I'll say I like this paper a lot more than Unifuzz. I think the justifications make a lot more sense when it comes to the metrics and the chosen targets. It feels less biased in nature, and you can kind of see that in the methodology they presented. And it does a good job of arguing against the current state of benchmarking and the problems with it, as well as I think that reachability and detection portion is an important distinction to make that I haven't really seen being made by any other papers or just anybody in general before.
Yeah, no, that was actually, I meant to bring this up earlier. It seems like a really obvious thing, but until they mentioned this paper, I hadn't even really considered, or kind of relate to that, is the triggering of a bug but not actually detecting it. So still being able to trigger, what would be the core issue, but maybe not getting a crash out effect, and just in general, does it detect it as an exploitable crash? So with this setup, like, they're able to look at, it's hit the trigger condition, it's kind of run through the code, so it knows that it should have detected the crash at that point, or knows it should have reached it. And then you can compare, did the fuzzer actually find it? It doesn't just artificially introduce the crash because it reached those conditions. And I think that's a really important distinction, as you're kind of bringing up there with it, because yeah, like, I just hadn't even thought of it beforehand, but it seems really obvious now that it's been pointed out.
So an example there of a bug that could be triggerable but not necessarily detectable is if you have like a stack overflow or an out of bounds write or read, but it's very small. Like you have like a off by one issue or something like that. Those are like really hard to detect, because not only is it not going to trigger a crash, it's also probably not going to trigger even if you compile with address sanitization, because it needs to be able to use red zones, which Asan puts in there. And if it's a really small out of bounds write, then it's probably not going to hit a red zone. So that's just one example of where you can get a bug that you can trigger. It is technically corrupting memory. It's just not easy to see. So that is one area that fuzzers do kind of need to improve on, and that can be an interesting benchmark for that kind of research going forward too.
Yeah, I mean, that's not even just fuzzers need to improve on, just any sort of automated detection on that, like just being able to detect those small writes, not necessarily because that's more in something like ASEN would be doing rather than necessarily the fuzzer detecting it. The
More on the
fuzzer's just
instrumentation,
detecting, yeah. And it's definitely a hard problem. Well, it's an easy problem to solve if you're okay with absolutely terrible performance. But assuming you want to be able to still run the application you're fuzzing, it's kind of a hard problem.
Yeah. So we'll move into exploits. So our first one is another one from Jonas Lick, who we've covered before in previous episodes with a bunch of Windows issues that he's dropped on Twitter. So starting off with a bit of drama, a very weird issue in Windows. From what I can read here, basically Microsoft changed the permissions on partition and volume device objects so that everyone now has read access. So as Jonas says in his tweet, if you just open the partition or volume device directly, you can read any file from an unprivileged context, even from inside of the Edge sandbox. So this seems like a massive oversight by Microsoft. I don't really know how this kind of change makes it into production. It looks even worse on Microsoft here because according to Jonas in another tweet, they had submitted the bug 4 times because Microsoft couldn't replicate it. Only after posting a tweet that they were, saying that they'd consider making it a public 0-day was it really taken seriously by Microsoft and eventually fixed. Which I actually I do want to try to confirm there. Did they actually say that it was fixed for sure? I believe it was.
Yeah, I'm not sure.
But yeah, like there's also a bit more weirdness with the CVE because I wanted to see if the CVE had any like additional details or anything like that. The CVE description had it as a kernel information disclosure, which I guess it's technically correct if you stretch it, but it's very different from how it sounds. It kind of downplays it because kernel information disclosure, like a memory uninitialized memory leak or something, especially in Windows, isn't super like uncommon or as interesting as it is in like Linux, just because of the way that Windows was built from all the legacy crap. So, but arbitrary file read, even from a sandbox, is very rare and impactful. So I don't know why the CVE description has it as a kernel information disclosure. That seems a little bit disingenuous, but yeah, there's a lot of weirdness surrounding this issue.
Though it's not the first time we're seeing CVs with weird descriptions out of Microsoft lately. We had something similar to that a couple episodes ago.
Yeah, I'm trying to remember the exact specifics, but I can't.
Yeah, specifics don't
bad.
matter. I'm just saying we've kind of seen that same thing before. Issues being reported, and the CV doesn't really match up what's going on.
Yeah, so judging by the fact that Jonas mentioned the CVE, I'm guessing that means it is fixed, but the reason I was a bit confused on that was the fact that the description was so different. It could be the case that it was a different bug they fixed and maybe there was just a confusion there. I don't know. It just seems it's a weird issue for sure.
A weird issue, but I mean, I like the fact that he mentions there that 7-zip will parse the NTFS, so open it with 7-zip and you can go ahead and navigate the whole file system like that. In terms of one of the things you can do with this, it is also worth knowing, like, SAM files, I think one of the big things is, stealing the passwords. Well, password hashes, but still.
Yeah. So, 7-zip, the number one hacking tool, can use that to hack Windows, or at least you could.
Yeah, and actually, I didn't even know I mean, it doesn't surprise me, given everything 7-zip can do, but I did not know you can just open the raw NTFS data and it'll handle it just fine.
I almost wonder if that kind of trick is why 7-zip is a little bit faster than, say, WinRAR and stuff, because, compression and decompression in 7-zip does seem to be faster. So I wonder if that could be a, potential reason. Just kind of a side point. Not too relevant.
I would imagine the code is pretty separate between, like, or are you saying that WinRAR will parse NTFS also?
No, I'm wondering if the parsing of the NTFS is the reason or a big contributor to the performance gains. But yeah, that was just something I was kind of thinking of when we were going through that. So ContainerDrip. So this is a credential leak vulnerability in Containerd, via the container image manifests, which allow foreign layers, so URLs from other servers. The problem comes in when that foreign layer is malicious and presents a 401 status code, which is an authorization required. When that happens, if someone pulls the image that uses that malicious layer, the credentials are then piped to that server to try to download the layer, which makes sense when you think about how it works, but that results in a third-party credential leak. So this was fixed in version 1.3 and 1.2.14. There is a bit of a limited impact because the victim would have to pull from a malicious image, which, I mean, if you're setting up like containers and stuff, you probably should be using trusted sources whenever you can.
There's
So
that. I do want to jump back before I move on too far and just point out also that with the 401, it does need to present uh, the correct realm for the credentials that it'll share. So you can, if you've got some random business and you don't know what realm it's actually going to be asking for those credentials to come from, you're not going to be able to exploit it. You're not going to be able to get to just send you some credentials. Like, it doesn't just send you some magic credentials. It needs to already have them kind of saved and know about them, and then you need to know how to reference them. That said, the case that they use here is pretty straightforward, being that they present themselves as the Google Container Registry. So you're looking at the realm there they put up as the realm as the gcr.io v2/token. So doing that, and if you're making this request from like a GCE instance, it'll send over the instance token, which you can then use. So that's kind of how they actually got a credential leak out of it. You do need a little bit more information than just, give it a 401 and it gives you back credentials. It's not quite so simple. And the credentials are just, you send it the www authenticate header with basic, so you're able to decrypt the credentials. If I recall correctly, it's just base 64.
the most secure encryption.
Well, I mean, it's not really being used as encryption. It's being used
No, I know, I'm just
so
kidding.
you can include any characters, and it's kind of safe to include in the header.
Yeah, it's being used what it's meant for, which is encoding. I was just kind of making a joke there. Because there are some people out there, for whatever reason, that think base 64 means they're safe.
Just use
Rot 13?
well, yeah, I'm sorry. For some reason I drew a blank on the number. I was going to say 2 raw 13, and then I couldn't remember what the rotation number was. So kind of drew a blank there. But yeah, just use 2 raw 13 and you're good.
A kind of side point that's mentioned in the article is I don't know if you saw this, but they have a bit of a defense of naming vulnerabilities.
So
I guess,
before you go there, still talking
okay,
about this issue. Sorry, I do want to talk
no
about
worries.
this issue at least a little bit here with kind of some of the difficulties. It is also worth mentioning here, this only impacts 1.2, which is already end of life. 1.3 does not have this issue. It just ignores any 401s coming from a foreign layer URL. And as you were kind of talking about earlier when I first jumped in, this is kind of a more general issue of just, trusting the containers you're pulling. And if you don't trust the container, you're already taking a huge risk. Like, a malicious container can already do like code execution on your machine. I mean, credential leaking is something else in particular. Like, I'm not denying that this is an issue. Just in most cases, you're probably not really going to be exposed to that. Like, this isn't going to be a widespread issue, which now goes into where you were talking. This is a named vuln. This is ContainerDrip. And they do include a defense on why they decide to name this vulnerability, being that a short, fun name is much better than rattling off a CVE ID. It's more memorable and easier to convey in conversation. And then they give an example for when a Kubernetes admin hears CV 2019 11.253, they might not make the connection. But if you said billion laughs DOS, they'll be far more likely to know what you're referring to without looking it up. That's absolutely true. That said, is this something you're actually going to need to bring up and convey in conversation? I feel like it's not that much of an issue.
Yeah, I mean, the impact is so limited because of that level of trust you have to place in order to get hit by it. So I would kind of agree there. I do agree with the defense itself, though. Like, taking this issue aside and just taking the defense in isolation, I think, the more meaningful and more memorable aspect of it is a very valid point. And
yeah, but I mean, let's say every vulnerability starts introducing a name. Like every vulnerability has a name. So we've had, well, this is CV 2020 15 15 7. So 15,000 different vulnerability names. Because there's been 15,000. Well, there's been more than that. We might even be in the 30s now. We're definitely in the late 20,000s. If every one of those vulnerabilities introduce a name for their bug, you're still going to be looking up the bug name.
Yeah, and as much as that defense does make sense, at least in this case, ContainerDrip is kind of, it makes sense as a name. They're dealing with container images and it's leaking. That's where the drip comes from. I think the problem with a lot of named vulnerabilities in general is the fact that the names are not really attached to the issue itself. Like, one that I can think of offhand is like, I think Cable Haunt, Raccoon. Like, there's certain ones that are just, they don't really mean anything on their own. You probably have to look up what it means anyway, which is the exact same thing you already have to do with CVEs.
Although ContainerDrip, I mean, if you're just trying to figure out what the deal is with that, I mean, are you going to think it's credential leak? You're probably not going to think credential leak. You're going to think some other sort of info disclosure, most likely.
Yeah.
So you need to already be familiar with the name anyhow. So I think it needs to be reserved for vulnerabilities that you're going to be talking about with kind of lay individuals. I'm less concerned about the Kubernetes admin as I am when you need a, well, actually, that's fair, actually, the Kubernetes admin. I'm just kind of thinking of the case like Cable Haunt, I think is kind of fair because that's one of those issues that you're going to want to be potentially have been talking about with kind of lay individuals, people who aren't technically knowledgeable. So being able to use that rather than the name, it's easier to convey. And you kind of need to use that easier to convey language for those types of individuals. So those widespread issues that impact general users. So that's also where, Spectre and like all of those issues come in, like the various name vulns. Yeah, like the various name vulns that we've had in the past couple of years.
There's been so many.
Yeah, there's been so many of those things. So I mean, those, I think, like, especially the first couple there with Spectre and Markdown, like, it's worth mentioning because that's going to be talked about and is relevant to the lay individuals who aren't security focused. This one, though, if just feels a lot less applicable in the general case. And we don't want to have named vulnerabilities for absolutely every vulnerability.
Which it does seem like we're trending towards. I mean, we have a few, we have more named vulnerabilities in this episode coming up too, so it's not like this is the only one. This is like
all named vulns.
Yeah, we got quite a few. So
actually, even the last one, from Jonas there, it's AKA Bits Please. So there's another name vuln for that too.
There you go. This isn't even the first one of the episode. They're creeping up everywhere.
Yeah, so, I mean, I'm just generally not a fan of there being so many. Like, since they mentioned billion laughs, like, that's still something you come across. And still something you can pull off. So, like, it's still relevant. That said, I actually don't know how many people really know it by that name. But they might. I mean, it's one of those things like
admin space.
Yeah, I mean, once you know it, you definitely remember that one.
Yeah,
But yeah, I think I've said my piece on the named vulns.
get the little rant out of the way. So we'll jump into Discord. So I believe this is the first publicized Discord RCE. I might be wrong on that, but I don't remember of hearing one before. So Discord, which probably everybody has at this point, is Electron based. So there's always been a bit of concern around its security because of how good of a target it is in theory for RCE, right? Everyone's running it. People generally trust it because it's a chat app. As long as you're not downloading files that are in there that are, from people you don't trust, you should be safe, right? But, there's always been that concern of, okay, if there's an XSS that somebody can abuse in Discord, then you're finished, right? And that's kind of been one of the big points against Electron based applications. So that's what this post goes into. It goes into 3 issues in Discord that eventually led to RCE through the Discord desktop app. So the first one is basically a defense in depth measure not being used that Electron provides, which is context isolation. So there's 2 important options when you're setting window options for Electron, being node integration and context isolation. So node integration basically means if that's set to true, you can invoke Node.js functions. So that being set to false is good, but the problem is context isolation is not set to true. So the problem there is a page JavaScript can affect execution in the internal JavaScript engine for Electron and can preload scripts. So that kind of circles back to that original point of concern, being able to use Node.js features.
Yeah, if I could interrupt you quickly and just talk contact isolation as like a feature. One, it is an experimental feature right now, so I can kind of understand why it's not being used. It is mentioned as it's experimental. And just kind of so everybody's on the same page in terms of what it does, is the idea similar to how you have content scripts in Chrome, and they're separate kind of from your actual page scripts. So content scripts being like the scripts that run your plugins, web extensions. And there's this isolation between those scripts and your page scripts. So context isolation within Electron is also just adding isolation between the page scripts and the preload scripts. It's also adding, between like Node itself, I believe, and the preload scripts. No, actually, that wouldn't make any sense. I'm sorry. It does isolate the page scripts though from the Electron internals. Essentially, it creates a separate context between everything. So sorry, go ahead. I just want to add in about context isolation.
Yeah, no problem. So the second bug is the XSS itself in the iframe embeds. So they looked at the content security policy to see which type of websites got these embed iframes and found the typical URLs you'll see embeds for: YouTube, Twitch, Spotify, Twitter, etc. They found one link, which was Sketchfab, which is a 3D modeling service that was allowed to be embedded, which I haven't seen embedded before. But they found an XSS on that page that would get embedded in Discord. It was in the footnote of the 3D model. So even these 2 bugs still wasn't enough because the XSS was in the iframe, and you couldn't use that to run code in the top level browsing context. So that's where the third bug comes into play. This third bug seems to be more on Electron than it is on Discord. Basically, navigation via the top.location accessor doesn't have the will navigate event caught, and therefore it's not blocked. So using the iframe, you can influence the top level browsing context location. So this one got a CVE since it's in Electron directly. So by combining all 3 of these issues together, RCE could be achieved through Discord. I will say I think this was a really cool write-up. It was clear, concise, to the point. There wasn't like a lot of filler like we've seen with some other write-ups.
Well, so there is, I won't necessarily say filler, but they do include all these slides partway through it, about abusing the lack of context isolation from a presentation a couple years ago. It's actually a really good set of slides, so that's why I'm hesitant to actually say it's filler. There's a lot of really good information in there, really good overview of it. I also just want to jump back really quickly and talk about one thing I thought that was interesting here. He looked at the code and saw that it was found the code that would restrict the navigation, so that the iframe couldn't actually change the page that the Electron application was showing. And so it would look at, or it would catch two events, the new window and the will navigate, and effectively look and make sure that they're valid navigations. So Spectre said the bug in Electron was that will navigate just never fired if the URL wasn't within the same site or same origin that it was navigating to. Which, yeah, definitely kind of a bug there. I just thought it's kind of interesting because the code was correct. So this is one of those cases where it's important, especially when you're testing things, test your assumptions, just give it the quick test. It would have been so easy to see this code and be like, oh, it catches that. Let's go look for something else. Whereas in reality, it doesn't actually catch that because this is wrong. So just testing those assumptions rather than assuming code always works exactly how you think it works. I just think that's a really kind of important point here because this would have been so easy to ignore. Had he not just gone ahead and given it that little test anyhow just to see what happens, you know, maybe set a breakpoint, just see that's getting hit, and maybe he can figure something out. So
it's one of those things we kind of talked about before, right? Don't implicitly trust the documentation. Verify the assumptions, because we've seen that with Windows API stuff before too.
Although
it was a long time ago.
Documentation. This is like, it's a little bit more than trusting the doc. Like, I mean, you can generally trust the code. It's really easy for code you see to be like miswritten, or in this case, it just doesn't work. Some that you'd miss. Like, it is a little bit more than documentation.
Yeah, just kind of along those same lines. Like, we've seen issues because of, you know, this type of trust before. So yeah, like I was saying earlier, really cool write-up. Like I said earlier too, this I think is the first publicly documented RC through Discord, so it's pretty notable there. This post is kind of a PSA about the configuration issues with node integration and context isolation, I think, especially if you're not super familiar with Node.js and, you know, front end for web applications or Electron and stuff like that. You know, I think that's a good notice for people to look out for that kind of stuff. So this post actually did the opposite of what a lot of posts we cover do, in the fact that it actually improved my stance on Discord security. So Discord has always been kind of speculated to be bad in a security context, and I didn't realize it was so hard to take an XSS to RCE. Like, I didn't realize there were so many defense and depth measures in Electron and how you could configure it. So now that context isolation is enabled, I feel like it'd be very difficult to pull off this kind of attack in the future, even if you get that initial XSS foothold.
So does this change your opinion about Electron at all, or only Discord?
Both. I think both of them kind of rise a little bit in my security expectations. Because just that defense in depth, I didn't realize Electron provided that, or that Discord could use that. So
yeah. I would agree. Actually, I wasn't. I've never done like an assessment on an Electron app. I wasn't too familiar with that. I have been familiar, obviously, with XSS to RCE. I wrongly made the assumption that they really weren't doing much beyond that. Like, if you manage to get XSS, well, I mean, it's still, if you get in the top window, there's a little bit less work, but context isolation should still kind of save you there. I do want to mention kind of one thing that really helped me with helped improve my view towards Discord. One, they did pay out a bounty on this, $5,000. That's not the thing though. Their response to this, they had this, so it was reported 9 p.m. 9:21 p.m. July 16th. That's when it was received. 9:34 p.m. it was acknowledged, and Sketchfab embeds they started working on the deployment to disable Sketchfab embeds. By 10 p.m., the update was pushed to stable to disable all of the existing Sketchfab embeds. So within about 40 minutes, this was patched.
Yeah, awesome.
That's an impressive response time. Yeah. And after hours, but I'm not sure how global Discord's team is.
So one thing I want to mention on that payout, I saw some people saying that $5,000 seems low considering the potential impact of an issue like this. I did want to quickly hijack that point and just say that it seems a lot of people expect companies to pay out the same, like what the exploit would be worth in like a black market context. Because, if you sold this exploit in the black market, yes, it probably would be worth a lot more. I don't think it's fair to do that though. There are companies out there that we've covered in the past that have had similar issues in terms of impact, how impactful they were, and they didn't even pay out at all. So I think 5,000 is extremely fair here. I don't think it's fair to go after Discord and say, "Oh, you should have paid more here." Five
So
thousand seems reasonable to me.
I think it's really important to point out to those people that this is not a zero-click RCE. You have to interact with that Sketchfab embed. After a couple clicks, then you get the cross-site scripting. That severely limits who you're going to be able to get with this. Now, I'm not sure what you actually need to do for the interactions. He only mentions that after a few clicks, he's able to get it. He mentions in the footnote, I assume you have to go and click in that footnote area of the embed. So that severely limits where this is going to be used. Ignoring that, like on your point though, like yeah, the value, and we've touched on this before, but the value of bug bounties, like companies aren't going to pay out what the potential damage was. Like, oh, you could have cost $100 million there for your bug. Yeah, we're going to pay. Like, that's the point of the bug bounty, is partially to save them money, partially just to encourage kind of the research, the openness towards researchers, rather than just treating them as criminals and going straight to court cases with anybody that tries to report an issue. As much as I'm a fan of the bug bounties, I do think there's just an issue with people having the expectation that companies are going to pay a lot more than it's really worth. And the black market is not a good way to value these bugs.
Yeah, you've got to keep your expectations reasonable.
Yeah, I do think, though, the interaction aspect would really limit how many people this could impact, and thus who would even buy it on the black market.
So earlier I was talking about some bounties not paying out. So we'll move into one that doesn't seem to pay out. The Department of Defense. So for obvious reasons, the actual service that was compromised has been classified. The injection happens. It's basically an SQL injection. It's a time-based SQLi, and it happens through the refer header to whatever service this is. So by making the database wait on a certain query, you can use it as an oracle to determine whether or not a result is true or false. So it's not like you could dump the database using this injection, but you can infer certain things and use it as an oracle. There's not a ton to talk about here because, especially where we don't know what the service is, we can't even really infer too much.
Well, to be clear, you can dump the database with a time-based injection. I mean, you basically dump it one character at a time. Is the first character of the string A? Is the first character of it B, C, D, and so on? Is the second character A, B, C, D?
Good luck with
you
that.
script it up. You script it up and you just leave it going. I mean, if you've got a lot of data, like you don't have good throughput with that at all, but you can dump just the raw data out of the database using the time-based. You just script it up. I thought this one was interesting because it's in the refer header. That was kind of the interesting aspect of this to me, and it's just a straightforward single quote in the header, and then plus and add your subquery in there, or add whatever you want to inject in there. Like really straightforward issue. It's just the refer, like I could understand it's probably logging all of the refers. It just seems like such a weird place for it. Definitely something that you could overlook.
Yeah, I don't think we've covered anything through the refer, but in a way, it kind of reminds me of that bug we covered a while ago that was the XSS through the user agent. Kind of similar in nature, that it's, in the HTTP header. This report is kind of funny though. It has those like CIA movie type vibes. It feels like a Jason Bourne movie with like the black bars and the obfuscation. You may notice if you go to the comments, the Department of Defense staff are listed as Agent L8 and Agent J5. It's pretty comical if you look at it from like the Hollywood hacker point of view. I do find it weird that the Department of Defense doesn't seem to pay out for issues. I even went to their HackerOne page, and yeah, they don't list any like payouts or anything. They don't have an average payout, so I guess they just expect people to, if they find issues or want to look for issues, just report from them. Obviously, there is a very strict set of guidelines. You can't exfiltrate data or anything like that. But yeah, I found it kind of weird. There was no bounty attached there. You would think, a company, or rather a government with the resources of the Department of Defense, would be able to shell out like $100 or something for this. But um, I guess see our last discussion with keeping expectations reasonable. Not everyone pays out. It's weird DoD doesn't, but you just gotta take it with the turf, I guess.
Yeah, I mean, I'm not sure necessarily if HackerOne is also their primary source, because there's like the whole like hack the Pentagon, hack the Navy, hack the Army, which I think predates their use of HackerOne. And I'm not sure if those have bounties or not either, because as a Canadian, I don't think I think there were some restrictions on that. I might be thinking of something else that had the restriction. I've just never really looked at the US government like bounties at all. But yeah, I'm actually just trying to look up if they have bounties, and it doesn't look like it.
Yeah, unfortunate.
Although, actually, I do see here Department of. So I guess I'll bring up what I'm looking at on another window. So it looks like they had the Hack the Army 2.0 initiative, where they did award like 275,000 for 146 valid. So there is at least some point. Oh, and with international hackers, there is at least some point where they are paying out a bounty. So it's possible that they're just not publicizing what any of the bounties are on HackerOne. But it does sound like, at least in some cases, and this is with specifically Hack the Army. Yeah, that's kind of how they name a lot of their programs: Hack the Army, Hack the Pentagon, etc. So it does sound like there might be something probably worth digging into a little bit more if that actually interests you.
We'll jump into our next exploit, which is a post about an issue with YAML, the YAML serialization library for Python. So this one is interesting in the way that it jumps around. It starts off as a design decision issue and a dispute between researchers and YAML maintainers. The initial issue came down to the fact that
PyYAML maintainers, that is important.
Yeah,
because
sorry,
YAML is separate from PyYAML.
Yeah. So the PyYAML load method loads the entire YAML specification instead of just the safe subset, which is problematic security-wise because PyYAML allows Python object and function serialization and deserialization. So you can effectively execute Python code via the YAML specification. There is a function to only load the safe subset, being safe load, but that initially wasn't the default method, and the documentation snippets use the unsafe load, and they point out how that's an issue because a lot of people, if they're new, they might just copy and paste that code and use it. So this was eventually addressed with PyYAML 4.1, but then in 4.2, they reversed that change due to compatibility reasons. So there was another dispute there being, is it okay to break backwards compatibility for security? And the researchers were on the side of yes. So it seems eventually PyYAML let up again, and in 5.1 they reverted back to secure defaults and added a new loader method, which would allow the serialization of objects, but not functions. And they claimed this would prevent code execution. Well, this post points out that that's not really true because you can still instantiate classes. So if you have a class constructor you can pass code to or commands, you can still get code execution.
If you've listened to this podcast for any period of time, I mean, as soon as I read that decision there, we just walked instantiating the functions and you can still do classes. Like, where this is going. That's just classic deserialization attacks.
Yeah.
Like, that's coming. And that's exactly what happened.
It's like trying to patch a sinking ship with glue. It's just, maybe it slows it down a little bit, but it doesn't really do anything.
Yeah, and
So,
just as a fun fact here, I didn't realize this. Map is actually a class in Python. So that's what they use. Map, function, and then X, what you're going to iterate or map over. So it's still basically instantiating a function. It's just, the class calls the function. In this case, map calls whatever function with whatever argument you want.
yeah, which can include commands. I will say there, though, that they mentioned map is a class specifically in Python 3. So I feel like that might have just been I'm not
That does
sure
seem
if
like
that
something
was
that would
specific.
be a 2.7 to 3 change.
Yeah. So maybe in Python 2, that's not the case. But
There's
yeah.
there's going to be more that you can use though besides just map.
Oh,
Map's
for
just
sure.
obviously an easy target. I mean, like I said, this is the same way most deserialization attacks end up working. That's it. I was a little bit surprised that it had this support. That this is not like proper YAML. Well, it is proper YAML, only in the sense that YAML supports customizable tags so that your own implementation can define these things. So like these Python objects and modules are all just Python tags that, or sorry, YAML tags that you can use specific to PyYAML. So don't worry about your random not Python project being able to decode Python objects.
This article was a fun read. There was a lot of back and forth and disputing and stuff. There were a few quotes that I kind of wanted to pick on and maybe have a bit of a discussion around. What do you think of that? It's okay to break backwards compatibility for security mantra in general.
I mean, it definitely depends on the situation. Generally speaking, I'd say, yeah, it's fine. I'd rather, software be more secure, but
I mean,
I,
part of the reason I bring that up is I feel like legacy and backwards compatibility is holding us back in so many areas, not just security. That's kind of what the Windows business model was built on. So I feel like the backwards compatibility argument is like hurting security as a whole. So if I had to pick one side, I would say I agree that it's fine to break backwards compatibility for security.
yeah, I mean, if I had to only come down one side, there couldn't be any gray. I'd agree with you.
Yeah.
I do think one other issue here is just the fact that this kind of went through the debate of should load work securely by default? Should we default, on the safe load versus normal? And it also kind of comes down to like who's at fault with something things. Like if you use load insecurely, I mean that's not PyYAML's fault. And one of the comments I definitely saw was, well, you just don't deserialize, user data. And I feel like in this case, that's a little bit unfair. First of all, there's kind of the expectation. The way YAML is used these days is around config files. Like this feature is a little bit surprising. Maybe if I actually, so I've used YAML a ton to like in writing config files. I've never seen it used for like this sort of serialization thing. That said, that could just be not really in the area that I've looked at. But that is worth knowing. Like I've never seen that, so it does seem like a surprising function to have in the YAML decoder. Could be a fair one. I'm not sure, but when it comes down, to blaming PyYAML, I saw some comments basically saying, well, if you didn't do any insecure deserialization, it's fine. And you're really at fault for trying to deserialize untrusted data and it has nothing to do with PyYAML. It's just you're misusing things. And I would definitely argue in this case, because PyYAML included that method to not include to not allow you to instantiate the functions, because they went and included that, I would argue that getting around that, bypass that, makes it a PyYAML issue. But if this were to not have happened, if that were just like they had a load and they had a safe load, and that's kind of what you were expected to read the documentation and know which one to use, then I think it would more or less be on the developer's fault. Not on PyYAML's fault. I don't know what you
I
think
think
about that.
I think the problem here, especially, is with the using the load function in the code snippets in the documentation for like getting started and whatnot. Because I think they even mention in the article here, not many people are going to need that serialization and deserialization primitive of Python objects. They mostly just want to use it to decode the YAML file. So why make it so that something that most people aren't going to use is available if it has a security implication, when you can just make it so the code snippets and the documentation says use the safe one, and then there's this other unsafe one that you can use if you need it, right?
Yeah, I
Kind
actually
of following
like their
that mantra
choice
of
for the 4.1 to use danger load and danger
yeah,
jump, because that makes it clear there's a security implication. I know they say they're not a fan of those names, but I feel like that's a great way to go about it, rather than having the dangerous one just be the load and safe load as the other option. Just as a side note, seeing like the danger underscore and the safe underscore definitely giving me some PHP vibes.
I mean, that's kind of where I was going to come down there, was you want danger to be highlighted, not safe. Kind of like what we were talking about with one of the things that Rust provides, is the fact that by default, everything you're using should be memory safe unless you use unsafe explicitly. And that kind of screams, I know what I'm doing here, or if there's an issue, look here first. Whereas if you use safe and just leave the unsafe one as the default, it's a lot less obvious when you're, auditing the code or whatever. So overall, if I had to summarize though, I would say it's kind of both faults on PyYAML and whoever's using PyYAML and not reading through and understanding that functionality. But if I had to put it more on one side than the other, I'd say PyYAML. I think the documentation should kind of scream it out at you more than it seems to at present, or at least when it did in the past. So yeah, that's
Yeah,
where I come down on it.
I definitely agree there. I do think like just the fact that PyYAML did kind of introduce a safer load and like the bypass, that squarely puts it in PyYAML's fault. But on the more general side of things, yeah, documentation should make it clear, and they should use the safe and sane defaults rather than using the unsafe version in like their examples for doing or for loading YAML when it clearly doesn't need. Because what was the example in there? Yeah, like doing just a couple key value pairs as their YAML document. They're not doing anything that requires like the Python tags. So they shouldn't be using loads. So, like, yeah, their documentation kind of showing secure code. And that kind of, again, gives me the PHP vibes because of, good old SQL injection. And if you look up any SQL tutorial in PHP, you get bad code.
Yeah. So it's been a while since we've talked about cars and hacking car systems. So here we have Phantom of the ADAS, or Advanced Driver Assistance System. So this focuses on Mobileye and Tesla, and something I just noticed when we brought this up, they have it spelled Telsa here, so Telsa and Mobileye systems. But it talks about split-second phantom attacks, and it is what it sounds like there. Basically, the attack is showing an image of something like a stop sign or a pedestrian or some kind of road sign for a few milliseconds, which causes the car to stop or take some evasive action. And it's abusing the fact that cameras and computers can see images way faster than human eyes can. And we've actually talked about an attack that abuses that fact before. The light can hack your face paper, or evil LEDs, which we covered in episode 45, also abuse this fact for backdooring neural networks. So they mention a few ways these images or phantoms could be created in the real world. Using like a digital billboard is one example they give, using a projector on the road. They have a white paper that goes more into the details of the maths and getting the timings down and such. At a high level, the phantom needs to appear roughly 200 milliseconds for Mobileye and 350 milliseconds for Tesla. So, they talk about that attack, and then towards the end, they talk about their countermeasure, which they call Ghostbusters, which I will say that is a 10 out of 10 name. And it basically just consists of using deep CNNs, or central neural networks, to determine whether or not an object is, an adversarial image or a real image. So using a training set to reduce the effectiveness of the attack, which when they tested it, they initially had a success rate of 80 to 99%. When they used a training set, it was reduced to like 0.01%. And that's probably just like more of a safety thing. You know, they don't want to say 0%, but it's decently close to that.
Yeah, and that's actually kind of the solution when it comes to a lot of adversarial attacks, is you have to train the AI, the model, on adversarial data, not just good data. So this is definitely kind of a different adversarial attack in that it's, these flat images being projected out, that it has no training to try and detect. Like, it's still kind of working properly. Like, the AI is properly detecting a person, a stop sign, something like that. Like, it's not wrong to detect that. And they actually kind of, in his presentation, I don't know if there's any screenshots of it in this. No, it doesn't look like it. But he actually spends a little bit of time talking about, this is not a bug. It's not poor code. It's not classic exploitation. It's not easily patched. It's just a fundamental flaw in the models. I'd still argue that's still a bug. Even if it's working as expected, it's the expectations that are wrong. But it is worth noting, like, it's not like they wrote incorrect code. It's the training data in this case that generally just, it's not even thinking about, is this fake? It's just detecting what's there.
So I wanted to call something out on that point. They have this, little FAQ section or whatever. I can't remember if it was in the page or if it was in the white paper that I looked at quickly. But they had this overarching question of, why does Tesla consider phantoms real objects? Wondering like why they didn't train, I guess, against problematic images potentially, being injected in there. And it comes down to better safe than sorry. And what I think is interesting there is this is actually an example of where that can be turned against you. For obvious reasons, if you're driving on like the highway or something, you do not want your car just stopping for nothing. That's going to really screw over the people behind you. So this is one of those examples where better safe than sorry isn't always true, and that kind of this attack challenges that assumption. So I thought that was worth calling out.
I kind of feel like part of it is also the fact that they're trusting. Now, I don't know what all the sensors are in Tesla, but I do know a lot from work around the visual. That Elon Musk has actually been kind of outspoken about not using LiDAR. And had they used LiDAR, it would be very easy to see that isn't a real object in front of us. And it just feels like, it's one of those cases where having more sensors and like different types of sensors would make sense for a vehicle. I'm not sure
Would have prevented this entirely.
Yeah, it just, like, when you have kind of one sensor that fails, you can have another sensor that's, seeing the correct thing. And you just need to, analyze that and figure out which one's correct. But just having the multiple types of sensors, I think, has value in protecting against kind of the attacks against one of them in particular.
Yeah, they kind of, I guess it kind of follows that mantra of trust but verify. You can trust the sensors but verify the sensors against each other to make sure that they're not getting attacked. I think that makes a lot of sense.
Yeah, fair point.
Up next, we have a Mozilla issue, a rollback attack, specifically on the Mozilla maintenance service. So this is a privilege escalation because the Mozilla maintenance service runs as system. And this was prompted by a CVE from 2019, which had a lack of integrity checks allowing privilege escalation through the same service. The issue here boils down to them they check the digital signature of the maintenance service since that CVE, but they don't check the version. So, even though they do that signature check, there's nothing preventing you from just rolling it back to an old version and using an old vulnerability or something to get a privilege escalation to system. So, after performing the rollback, it was basically just a matter of choosing an old vulnerability to use.
Yeah,
They chose.
I mean, you've kind of jumped right into how that worked, but we should probably mention how the Mozilla maintenance service actually worked, which is just that basically it's part of the update service. So it would check these files and then copy it would check like the update.exe and I want to say update.ini, but it might have been a slightly different file name for the ini. But it would check those two files. Obviously, the exe it would be checking for its signature. But it would copy those and then run the updater as system. So that's where, or that's kind of just, it runs it as system. So if you can control that binary, if you can replace it with something you're running as system, that's kind of just why I want to point out how that works before we get into the fact that you could replace it. What's it doing?
Yeah. So what you were saying there with updater.ini, that is protected because that is part of the attack they do here. They chose CVE 2017-7766. It consists of two bugs. One is an arbitrary file overwrite capability, and the other one is an arbitrary file execution. So they use the arbitrary file overwrite to overwrite that updater.ini settings file in order to control the path of the executable, which is launched after the update is applied. So, by changing that path, they can hijack the directory where it's executed from. Now, that executable that gets ran is expected to be Mozilla signed, which is what we kind of got with earlier with the CVE that they patched. That patch was making sure that that executable is signed, but you can get around that by doing a DLL hijack because you can control the path. So I think it's this is a cool post. This is a guest blog post on the Mozilla page, by the way, which is something I don't think I've seen a guest post on the Mozilla pages before. I could be wrong on that, but
no, but their attack and defense blog here is pretty new. I know we talked about when it launched on one of the episodes, so I want to say it's less than a year old.
Yeah. It does surprise me a bit that Firefox even had this issue. You would think rollback would have been considered for privileged executables. I guess it's just one of those things that's easy to skip over, though. But this blog is just another good PSA. Don't just check signatures, check versions as well. You don't want attackers to be able to downgrade executables of higher privileged binaries, even if they do, are signed digitally.
Yeah, and it is worth mentioning here that this does, I believe, require that Firefox be installed to a non-standard location. Just that a normal user isn't going to be able to change these files if they're sitting in program files. You have to install Firefox somewhere outside of the program files directory, outside of an admin-only directory. Otherwise, it's just admin to system, which is not an issue that Firefox or that Mozilla or like Microsoft care about as much. Just because going from admin to system isn't as much of a security concern.
Microsoft security boundaries can be a bit annoying in that way, that certain privilege escalations that would normally be considered privilege escalations, at least in my opinion, they don't care about. And yeah, that's a good point to bring up. So I love our next attack. It is glitching the MediaTek BootROM. So I love glitch attacks because, hardware is just that mystical realm that you don't get to see stuff from all the time. It's important to note that this attack specifically is on the MT8163 V chipset in the boot process. It probably does affect other newer chips. They just don't confirm it in the article. Getting a bit into the attack, though, they walk through their attack, which is a fault injection via voltage glitch on the BootROM when it loads the preloader. The reason they chose this is because it's higher in the chain of trust than Trust Zone and Untrusted Linux. So that's kind of a common point to attack if you want to hit bootloaders. You want to hit it before it even gets to Trust Zone. So what they target is fairly obvious if you've seen attacks on bootloaders before. They target the signature verification on the preloader image, which, according to their measurements, is about a 700 millisecond window. Pretty big difference there. But that does seem like a very large
really
window.
big window to hit 700 seconds.
Even 700 milliseconds, though, does seem like a pretty large window. I was a bit surprised that it was that big. So they use an FPGA, Field Programmable Grid Array, for those who don't know. It's fairly common to use an FPGA when you're glitching fast chips. I think the chip they're targeting here runs at 1.5 gigahertz. only an FPGA is going to be fast enough to hit those precise timings in most cases. The hardest part of glitch attacks, though, is figuring out the exact timing to, drop the voltage or drop the frequency or whatever type of glitch attack you're doing. The timing is really tough to figure out because you have to fire it at the right time to trigger it, and you don't want to hold it for too long. If you hold it for too long, if you drop the voltage for too long, the system crashes, you get a blackout. If you hold it for too little, you won't trigger the attack, or you might trigger something different. So this post gives a little bit of insight on that front and how they figured out the glitch parameters. Essentially, they brute forced it, which, makes sense. That's probably one of the more common ways of figuring out the timings. They also give insight on how you could mitigate these types of glitch attacks from the software side. So some of the things I mentioned are redundant checks to require multiple successive glitches, which, drastically reduces the success chance, random delays to throw off the trigger timing, and control flow integrity. So they provided the source code for the glitch. Overall, I thought this was an awesome post, though. I've said before, I love glitch attacks. They're just so mystical in nature, and it's one of those things where even if the code is written perfectly, the hardware is still, if you don't trust the hardware, then that doesn't necessarily matter. You can just make it so that the processor doesn't run the code properly. And what I liked about this post was it shed some light on that timing aspect and some of the setup that's involved, which is sometimes hand waved, I find, in posts or videos about glitch attacks, because a lot of the time it is target specific. But even still, I think there's definitely things you can take away here if you wanted to get into glitching. I think it's very accessible to people who aren't familiar with the field.
Yeah, I would agree. This is definitely very accessible, and I'm not somebody that's very familiar with the field. I did also just on that note want to mention it sounds like they mentioned at the top, yeah, this research was conducted by our intern. And I won't try to say the name, sorry, but sounds like, doing this sort of research, getting up to speed on something and documenting it is part of the NCC group internship, which sounds like a really solid thing to have in the internship. So I just wanted to shout out, because I know there's a lot of people that kind of look for those entry level security positions. Sounds like, NCC has a pretty decent internship program.
That being said, I'm not sure how open it is. It might be one of those things where you kind of have to know people to be able to get into that position.
They're often, going to be quite competitive, because it's usually these types of internships are they might fill 4, maybe 8 positions or something as interns, and there's a lot of people applying.
They're highly coveted, yeah.
But still, overall, I mean, if it's something you're interested in, I did want to shout that out. We're looking at the results of at least one of the interns' work.
Yeah. Overall, jumping back to the post, though, another thing that I liked was those insights on how you could mitigate the attacks from a software angle. Because usually these types of attacks on the hardware, it's easy to feel helpless against them. There is hardware protections against these types of attacks, but if your SoC doesn't have that built-in protection, it can feel like you're screwed. So I like the fact that they added the software stuff in, just adding those redundancy checks and stuff like that. It's something you can do to try to mitigate it, even if you won't stop it completely. And in many cases, that's the best you can do. So I wanted to call that out. I think that's another useful takeaway from the post. Moving on to AssaultCube. So getting into some game RCEs, which we haven't covered in a little while. This was a write-up by Elon Glicksberg. And it's an article based on AssaultCube, so you may or may not have heard of this game. It's a fairly old open source game. This is a client-to-server RCE, not a client-to-client RCE, which is a lot more common when it comes to game exploits. So after doing some searching, doing the initial recon phase,
so I do want to jump in and just say one reason why client-to-client is so common versus client-to-server is you're often kind of working blind when it comes to the server. You don't often have the ability to just run the server. I mean, some games do provide it, especially now. That's, you see that being provided, but No, no, it's just worth noting, like, that is kind of a special case, whereas client to client, you're able to run a client and actually, kind of attack yourself to do all that debugging. So that's kind of why client to server just isn't quite as common.
Easier to test. And
Yeah.
the other thing is too, if you don't have like a server binary to run or something, it's also a lot more legally questionable. If you don't have permission to be targeting the server, then you shouldn't be targeting the server, generally speaking. So that's another reason why client to server isn't as popular. But jumping back to the issue, they found a logic bug in the processing of one of the message commands, and it's the command dealing with setting the primary weapon, I assume, from the code. It seems like they try to do a bounds check here, so they have like a weapon index, and they check a user provided index for the next primary weapon. So they try to do a bounds check if the index is negative or if it was over the number of guns that they had, and they try to bail if either was the case to avoid the overflow. There's a small problem here that you might be able to spot, and it's basically the fact that they use an and condition instead of an or condition. So effectively, what you have here is dead code. The index will never be both negative and positive over the number of guns the player had. So the bounce check is basically useless because it's never going to fire. So, they played around with that. After some searching, they found a function that would call spawn state, which could give you a relative out of bounds right of a random integer using that issue.
Yeah,
So
so
that
that issue, what it would allow for anybody kind of just listening who can't see the code is if it didn't break out of that case, it would set the next primary in the kind of a, I'm not sure if it's a global, but a global or possibly global state value, or at least it's being passed around
I think it's a
state
client
value
state.
for the next primary. And so you control the value of uh, that next primary value. That's kind of the one you get control. And then as Spectre was saying, then you get to the spawn state, which ends up doing its own check, or which ends up assigning ammo based on that, in one case, based on that primary value. So that's, you're getting your right from. Carry on.
So what you were saying there with it writing the ammo is a little bit problematic because you don't entirely control what's being written with that relative out of bounds right. It's writing whatever the ammo count is. So it's not random, but it's also, I mean, you can control it if you fire a certain number of bullets in the game, I guess, but you don't have full control over what's getting written there. So that gave a crash, which could crash the server and would really annoy players, but they wanted to take it a step further to be able to get RCE. Basically, they abused that relative right to smash the message queue vector capacity to trigger another overflow, which was more promising. And this smashing allowed you to send messages that would overflow into the demo record object, which allowed you to smash a vtable pointer. And this is pretty cool because it gives you instruction pointer hijack right away by being able to control where the vtable points to. And furthermore, you also control the first argument that gets passed to the function called in the vtable. What's not so cool is the messages are expected to be ASCII friendly for obvious reasons, which means you were limited on your vtable hijack. You couldn't just write any pointer in there. Like you couldn't have a pointer that had null bytes in it, for example. So because you're smashing the pointer to the vtable, you would have to substitute a pointer in to something that acted like a vtable, but contained a controlled pointer you could jump to. What they decided to go with there was the global offset table. So they found a function in the GOT that had an address that consisted of printable characters. And then they wrote a script to do that. And after trying a few things, they ultimately went with syslog, which they used to pull off a format string attack to write the system PLT into the strcomp GOT slot, which you could then use to run shell commands by just sending text messages. Now, the attack is a bit more complex than it might sound. You do need to use another client to exploit the format string issue because of the way the client's vector worked. But what I liked here was this kind of reminds me of browser exploits in the complexity and like multiple layers of corruption. It's not just a straight up overflow like you sometimes see in older games. You're getting one small corruption primitive, and then you build on it to build more useful primitives until you eventually reach that end goal of code execution, right? So here they're going from the relative out of bounds right to create a more powerful heap overflow to then eventually create a format string exploit, which then leads to the code execution. It's a lot more complex than I was initially expecting it to be going into it. And, it just had that kind of browser feel to me, like I said earlier.
Yeah, that's fair. It's also just a really well done write up, I think. Like it does spend a little bit of time. Maybe some things are a little bit wordy, but generally it's a very clear write up for all of the steps involved. At no point did I really feel like I need to go back to re-understand something or to take another stab at understanding what was going on. I was just able to flow right through this one. Like, it's just a good write-up.
Yeah, and there were lots of like screenshots and videos and stuff along the way that you could check out if you were interested in seeing kind of what was playing out based on what he was talking about at the time. Furthermore, there is also code of the forked AssaultCube and the malicious client that he uploaded to GitHub. So, there's more than just the write-up there. There's also some other things you can check out if you're more interested. There's also a fun little Easter egg at the bottom saying the vulnerability was introduced on their birthday. So, there are some forces in the universe, I guess, that willed this to be. Moving on to another software that I never thought I would see a write-up for, AMD Ryzen Master. So this is a privilege escalation via AMD Ryzen Master. Like I said, something I never thought I'd see a write-up for because it's such an obscure application. It's not an everyday application. For those who don't know what AMD Ryzen Master is, it's basically a tool used by PC enthusiasts for overclocking and tinkering with Ryzen CPUs. So the bug here is in the driver used by that utility, so it's technically a Windows kernel bug. So they started out looking for code paths that could reach the map IO space Windows API function. So right away from their recon, you could see they were going from that sync to source mentality, looking for dangerous functions and then see if they could be reachable from the user in some controlled manner. Now, I'm not a Windows researcher, but I believe this function is dangerous because it can be used to map a physical address range to a virtual address and return it. So if you can control the parameters to that function, you can make it return a virtual address of where you want to do something interesting with, like writing to it or reading from it. So they found such a routine that accessed this function via ioctl because, of course. So that gave them arbitrary write. And they reasoned if it was possible to do this for arbitrary write to be able to get control of those parameters, there's probably another routine that does the same thing in reverse, allowing that function to be called for reading. Since usually with ioctls, you have pairs of functions for doing both reads and writes. So that gave them arbitrary read and write. And when you get arb read and write, especially in kernel, the game is over. Especially with Windows, you don't even need code execution. You can just use it to egg hunt memory for a privileged process security token and write that token into your own process to escalate it. That's exactly what they did here. They found the LSAS process, which is the authentication service. They found that token, then they swapped it into their own command.exe process to escalate it to system. So in terms of timeline, there is a POC attached to the write-up, by the way, which is cool for anyone who wants to look at that. But it was reported May 1st, 2020. They then said it was fixed sometime in August, because that was when it was resolved, and then it was disclosed last week. But we always want to bring attention to kernel stuff. Kernel is a fun area to look at when it comes to exploitation. There's a lot of unique challenges that you don't necessarily encounter in user mode. On top of that, a lot of the kernel stuff we cover in the past is Linux or Unix based, iOS or Linux or Mac OS or Android. So it's nice to be able to cover some Windows stuff for a change. And I definitely learned some stuff here because, like I said, I don't really do that Windows stuff. So, it's always fun to learn some new stuff and stuff that I don't really look at.
Yeah, and I mean, to some extent, we've kind of had the last couple episodes be pretty high level issues, a lot of web stuff. I was just happy to start seeing some binary stuff being published again to actually talk about.
Yeah, mix it up. And getting into more low-level issues, we have issues in Qualcomm. So these were bugs in Qualcomm's QCMAP mobile data modem SoCs. So these bugs were discovered using the vDoo integrated device security platform. I think I said that right. which is the product offered by the authors of this blog post. So
I mean,
three of
if
the
I had to
bugs
make a guess, it might be Voodoo. I mean, it doesn't
could be
necessarily
Voodoo,
look
yeah.
like that, but given the name, I just feel like Voodoo's probably. I mean, this is not related to the bug at all. This is just pronunciation issues.
Pedantic. Yeah, we'll say Voodoo, just to make it easier. So three of these bugs were in the connection manager and web client binaries, which were exploited through the web panel. And what's notable there is the web panel is not always behind HTTPS. It seems like it's kind of context specific. The fourth one was in the command line utility. So going into the issues, the first one was a command injection in the connection manager. They allow you to set a media directory to publish from, so the set media dir action. Using that action, you can literally just inject a semicolon to terminate the command early and inject your own commands. So, not a very hard issue to understand.
Yeah, and they also just point out this general pattern that ends up coming out in another issue. But just fact, like when they're creating these calls out to system, they're just doing sn print and kind of generating the string without checking. So in this case, and in the other case, it's just injecting a semicolon, and away you go. That's generally just one of those code smells too, is trying to dynamically generate this long string that's going to be executed by something like system versus using like a more parameterized call, which would be more ideal to use something that's kind of aware of arguments.
Who needs sanitization? So the second issue was a stack overflow in the web client. It takes in a list of variables from the URL and tokenizes them in the format of key equals value, and then they copy these values into an array of strings, but they don't track the number of variables that are passed. Furthermore, they use strncopy, but they don't use it properly because they calculate the length by the input string length, not the destination length. In fairness, that is actually kind of easy to do if you're not paying attention. I have caught myself doing that before. But what exacerbates that issue is the fact that there's no mitigations like Pi or stack cookies or anything like that in this SOC. So a stack overflow without stack cookies means you can get code execution with that, probably, in most cases. The third one was a null dereference in the same function as the last bug in the tokenizer. They use stir to look for an equal symbol to start reading from for the copy of the variable string values for the key equals value format. So if you just don't include the equals, it takes it returns a null pointer and it passes it to stern copy, which causes a crash. And then the last one was similar to the first issue. It's almost identical. It's another command injection. You can set a gateway URL, which constructs a string and calls system to spawn a new process. Again, you can just use a semicolon to break out and inject commands. So timeline here is a bit weird. The issues were reported in June of 2020, but the vendor said these issues were already patched in 2019, and they plan to disclose them in October of 2020, which does seem weird. Why would you plan to disclose them a year after they're already patched? It kind of seems like they were just downplaying it to the report, but maybe, that's just me reading into it. That's just speculation. I'm not saying that's for sure what happened.
Well, I don't know what the process is for actually updating the SOCs with something like this. Like, it feels like it's probably, a pretty long and slow process.
You would probably just have to produce new chips. You probably couldn't hot patch the old ones very easily.
Yeah, so that's why it could be that they were patched in 2019, but it's not until their actual next release or something like that they actually
fair point.
Get that out. Just trying to be charitable with that.
Yeah. So some of these issues I think are less forgivable than others. The command injections were pretty easy to get right and deal with. I feel like there should be alarm bells ringing whenever you're writing code that takes user input and passes it to something like system. Generally, if they're doing that, even if they sanitize, that's already an area of concern, I guess. The fact that they're doing it unmitigated, no sanitization, nothing, is just I don't really think that's excusable. I can't really be charitable in a way of thinking, oh, maybe they could use it for this. No, it just seems like lazy code.
No, and I
Um,
agree. I mean, I was trying to be charitable on the disclosure, but I also can't be charitable when it comes to that issue. Like, that's just plainly wrong.
yeah. Like I said with the Stern copy issue, though, it is a little bit easier to forgive. Um, I mean, I could say, yeah, like it should have been caught, but it's an easy enough mistake to make. Just using the wrong length, using the source one without thinking about it.
Well, it's
Um,
that, and it's the fact that it's an infinite loop. I feel like that infinite loop should have been something else. Like, they should have been tracking the number of uh, bytes written, which kind of comes down to the STRN copy, because since they're not tracking that, they can't really use STRN copy correctly, because it is kind of that looping right.
yeah.
They need to kind of be tracking that, but that's also just something like that shouldn't be a pretty much infinite loop, just ever.
More lazy code.
Without like some break condition on like the amount of bytes or something. Yeah. It's just like the whole structure here just screams that there's more vulnerabilities.
Just gotta love IoT.
I mean, I know everybody's worried about Huawei devices, but you know, maybe Qualcomm needs some light shined on it.
Yeah. Yeah, I feel like this is like a pinnacle or a case example of why IoT sucks. I feel like if you need somewhere to point, this article is a good one to point to. That being
Uh,
said,
I mean, there have been some worse cases for IoT stuff. Um, I
which
mean,
is
I'm
sad.
not trying to say this is great, but there have been some, I'd say, even worse cases.
The bar is low. We'll summarize it there.
Yeah.
So we'll move on to the big fish of the week, which was the ICMPv6 router advertisement issue in Windows. So Microsoft released an advisory that they fixed a bug in the TCP/IP stack, which was this issue in the neighbor discovery protocol when handling router advertisement packets. So this is an issue in the kernel, so it's another Windows kernel issue. So it's potential RCE into kernel land, which is scary on the surface, I guess. There was a little bit of FUD or fear, uncertainty, and doubt going around with this, though, which I think we'll get into a little bit later. Basics of the issue, though, there's a length field in the recursive DNS server options in the router advertising packets, and the length is in the units of 8 octets. So, because there's a reserved option for the metadata fields, including the length itself, that should comprise 1 unit, and then the IPv6 address should occupy 2 units. So that means the length should always be odd. Problem comes in is, what if it's even? Well, if it's even, the network buffer isn't advanced properly because it's not expected. So it's advanced 8 bytes lower than it should be, which means the last 8 bytes of the option are interpreted as the first 8 bytes of the next option. And that's problematic because the first option contains important, usually trusted, or validated metadata like the length. So there's a misalignment issue there due to, a logic bug. So this can give you a stack-based buffer overflow. So the write-up from Pi3 here goes through exploiting that bug and tackling some of the challenges and hurdles that came with it. Passing some of the validation checks to reach the bug and choosing a header for the message to be able to reach it.
Yeah, as
Um,
usual, like this guy's blog is very detailed in terms of the process. Like, he includes a lot of information here that you can uh if you're learning, definitely a good source to look at. Sometimes feel like it's long. Uh but that is kind of common for this author.
Goes through more of the recon phase and the challenges you can encounter if you're new to an issue.
Yeah, definitely
So
worthwhile information to know, like how he approached some of these problems, some of the thought process there. Like, great information. It definitely kind of wears on you as you keep going through like over and over all these different things. But I mean, like, they are the actual issues that he ran into, and that's an important thing to see, because so often, we do just kind of focus on here's the end result. Hey, I saw this and I got RC, and like kind of the frustrations between there, and all of the frustration you need to embrace when it comes to vulnerability research. This kind of shows that.
it's something that's often left out of write-ups.
Yeah.
Yeah. So this is a cool bug, and I like the write-up. Like I said earlier, there was some FUD around this, mostly because all of these POCs, and including the write-up itself, stop at a crash or blue screen of death. Why? Even though it's a Stack Overflow, you can't just do a stack smash and overwrite the return address because there's stack cookies in the way. And remember, we're talking about kernel here. You can't brute force the stack cookie. One crash and you're done. The system crashes. So there's no way that you could exploit this without using another bug, using something like an info leak to be able to leak the stack cookie. And something that people seem to be leaving out, like, this is another one of those bugs that the media kind of picked up and people were commenting on, running away with, saying, LOL, a TCP/IP stack bug, another like end of world type, scenario. No, because info leak, especially from a remote perspective, is extremely difficult to do. Remote info leaks are rare because you need to be able to exfil that information back to be able to exploit the leak, which just remotely in the past has shown that that's not easy. And that's one reason why, even when we were talking about a game RCE earlier, one of the hardest things with game exploits is, sure, you can find a lot of memory corruption issues, but defeating ASLR and getting that info leak is just so difficult because of the nature of what you're doing over a remote connection compared to local. So, it's not like this bug could be abused on its own to be able to hijack systems. You need another bug to chain with it, and that other bug to chain with it is not trivial by any means.
Yeah, and to be fair, like, that's common. When we talk, like, oftentimes when vulnerabilities are reported, you have and especially when we're talking about researchers reporting vulnerabilities, they report their RC, and it would, if they had an information disclosure, that would be a completely separate report. It's a completely separate bug. It's something totally different. I mean, yeah, there are exploits where you have like a really powerful gadget or some exploit technique that doesn't require a leak. But just generally speaking, like, this is a common thing to only have half of it, and the media likes to run away with those and be like, oh my god, this could have, been so damaging. And I just think of like all the WhatsApp hype around some of those issues. I mean, in one case, actually, like, it was valid. It was found being exploited in the wild, and they did have the full chain exploit going with it. But when it comes to some of these reports, like, it is normal for it to not be exploitable just like this. That's totally fair. It's still a issue, but as Spectre's saying, like, it's going to be rough, especially as a remote attacker, to exploit this. And not just remote, but you do have to be local on the network. You can't just be over the internet, so that limits who can even attack you with this. Kind of where the neighbors come from. So that's just another limitation on this that makes it difficult to actually exploit.
Yeah, so to be clear there, I'm not like going after the write-up or any of the write-ups or POCs or anything there. Mainly just how people are perceiving it and kind of running away with it as if it's, doomsday. When
yeah, just the people who don't understand what they're talking about.
Yeah, in reality, this issue, I doubt this issue would even ever really be used because it's just, there's too many specific circumstances that make it not that viable for someone to use to attack someone.
I mean, it's, on one hand, let's just assume you had the info leak. This seems like it would be a reasonably stable place to attack. If you had the info leak, you can get the stack cookie.
But that local network access is a big requirement too.
True, so but it's not you just could use this malware. Well, I cannot see malware, dropping ODAs or anything. That's usually not what malware's doing. But I mean, the network access limits it, so like, this isn't going to be a widespread attack. But it's not crazy to think that some APT group could get on the network of their target. So like, I think it could be used. It's not going to be like a mess of spam.
It's not going to be used for worms.
It could be used for worms, actually. Once they get onto the network, scanning everything local. Which is, part of it is get into one network, get onto everything in that network. And then from all of those devices, you scan the internet. I mean, obviously, some just kind of scan the internet, don't even look on the network, but scanning the network on a worm wouldn't be that uncommon.
Okay. But getting that initial foothold is still like a major limiting factor.
Oh, it's definitely a limiting factor, yeah.
Yeah. So we have a V8 exploit as well, sticking with the complex bugs. This one talks about a type confusion in V8 that was reported a while ago to lead to a null dereference in September of 2019. But what's notable about this post is the initial bug was thought to be unexploitable outside of denial of service due to null dereference being something it's been dead for a while now in that regard of exploitability. And in browsers, DOS isn't really a huge, concern typically. Um, the bug is basically in the node graphs they use for generating optimized code. So they have nodes for input nodes and user nodes. And as I understand it, the optimizer can basically traverse that graph for JIT compilation and purge the ones that aren't relevant or needed, right? So it's in that optimization pipeline. But the use nodes contain an input index, which is limited to a 17-bit bit field. So one of those questions arise: what happens if you overflow the indices by constructing a graph with a large amount of input nodes? When that happens, you get a type confusion because you can then mix up the node types. So the original way of exploiting this bug in the original CVE was using WebAssembly to abuse the bug, which due to the code flow, it could only trigger a null pointer dereference, so it wasn't super interesting. But these guys managed to exploit it using JIT code via the reduce.js call. So, JIT obviously is going to take a different code path than WebAssembly. It's a lot more of a complex code path, which is probably why WebAssembly was initially chosen in the first place. This bug exists in the compilation of JIT code before it gets optimized, which makes it harder to exploit compared to bugs that exist in the optimized JIT. Optimization introduces factors of uncertainty, things you have to work around. But what was cool here was they managed to turn that disadvantage into an advantage. JIT bugs pre-optimization are hard to exploit, but they use that optimization and their type confusion foothold to eliminate like bounds checking nodes by changing the opcode of the node with the type confusion. So by doing that, that allowed them to gain further corruption to eventually cause another type confusion, which gave them the arbitrary read-write. And I kind of referred to this earlier, but in browsers, it's very common that you don't just go straight from an issue to code execution or arb read-write. Usually you need to go a few stages of corruption to be able to get there. And this is another example of that. The type confusion on its own can't be used to get immediate code execution, but they use that to influence the optimization pipeline to be able to create further corruption primitives, which is just, it makes for a lot more interesting attacks than those just straight, stack smashing or something, for example. And that's one area where I love browser exploitation. I think this post offers a lot of useful insights into V8. When you're talking about WebKit browser exploitation, WebKit kind of dominates the space. You don't really see too much when it comes to V8 and Chrome and stuff like that. So I think this is a very insightful write-up that can be used by other people who want to look at V8 stuff as well.
Yeah, it took me a couple reads to kind of get, well, in at least a couple areas, kind of get everything. But yeah, it includes a lot of good information if you were going into V8, and it's just nice to see something besides WebKit. I did like this. Sorry, I did like this technique though of using or abusing the dead code elimination pass to remove your map checks and bound checks. I did just find that kind of a cheeky way to get your exploit.
Something that most people probably don't even think of. One thing I will call out, I do like the article in general. The title is a little bit weird though, because it says a new technique to exploit V8 null pointer dereference bug. It makes it sound like it's a way to abuse null pointer dereferences across the board, like it's some null page guard bypass or something, which isn't the case. It's just that in their case, they had a type confusion that usually led to a null dereference, and they managed to take a different path to skate around it. It's not like they're exploiting a null pointer dereference, which I just think the title could have been worded a little bit better because it was a little bit misleading in that regard. I thought
Yeah, but
initially
this
that
is way more clickbaity.
yeah, exactly. Initially, I was thinking, wow, that's really neat. It's been a long time since I've seen something that allows a null pointer to be exploited, and this could have implications across other bugs. But no, it's specific to this one. So just keep that in mind that it is just skating around the null pointer dereference. Don't get too excited thinking that null dereferences reported in the past are suddenly more interesting. They're not. So, another big fish of the week, BleedingTooth. So there were some bugs reported by our friendly neighborhood, The Flow, also known as Andy Nguyen. These were 3 Linux kernel vulnerabilities in the BlueZ, which is the Linux Bluetooth stack. So there were 3 issues. One was a heap overflow in the HCI event packet parser. This was introduced in Bluetooth 5, which extended the advertising payload capability from 31 octets to 255. When they added this support, it seems they copied and modified the code that was used for legacy with 31. And when the advertiser is using an indirect advertisement and the recipient is doing active scanning, a code path is taken which uses the expected 31 from before. So it's possible to pass a length greater than 31, which leads to a heap overflow. So that gives you heap corruption in the HCI dev structure, which is a pretty decent struct to hit. It looks pretty exploitable based on the members around it. They don't put out like weaponized exploits for these issues. It's mostly POCs and a summary. If
Though the
nothing else,
analysis is really good on the Google security advisories.
yeah. If nothing else, though, with that issue, you could hit the length or some other count to get further corruption. Was there something you wanted to add on the hate-based one that I missed? I didn't just note that you pulled it up and scrolled down to something, but
Yeah, well, I pulled it up so the link would be in our show notes.
oh, okay, fair enough.
Instead of just looking at that. I was also going to mention that since we've been talking about the name vulns, technically it's BleedingTooth, and then all of these 3 vulnerabilities have their own names: Bad Karma, Bad Choice, and Bad Vibes.
I didn't even notice that.
We've got nested name vulns.
We don't need this. The other issue was a stack-based info leak. When you gave an invalid device ID, an error response was sent, and that error response had uninitialized struct members. This one was probably the most straightforward issue of the 3. They just didn't zero out the memory or initialize it to avoid info leaks. These are very easy mistakes to make, by the way. They're very easy oversights to make in code, which is why I want to say there's a kernel config option where you can turn all malloc or kmalloc calls into kzallocs under the hood. It wouldn't help you here with a stack-based info leak like this one, but it does avoid heap ones, and it does just go to show that it's so easy to, put a struct on the stack or in the heap, initialize the fields you're going to use, and just ignore all the other ones and like the padding and stuff. So just a kind of moral of the story there is always just zero initialize your objects before you pass them to untrusted users, because that uninitialized memory, especially in kernel, can contain some very useful pointers, literally pointers that attackers can use for more powerful attacks. The last issue was the most complex. It was the type confusion in the L2 cap subsystem. This subsystem is a little bit hard to understand, but basically there's like channels, and you can specify channel IDs and a channel mode. And the problem arises is if you specify a channel ID that's different than the common ones, and I think the one they give here is A2MP, it creates a channel and initializes it with a mode for you. When that happens, it initializes the channel data with a certain structure, with the AMP MGR struct, which makes sense due to the channel identifier being the A2MP. But the problem is the filter that's then used on the receive function for packets, it expects a socket object, not an AMP MGR object on that data container. So there's a type confusion there, right? It's being treated as one type of object in one place and a different type of object in another place. Type confusions generally are the most complex issues to understand, mostly because they're very context specific as to how you can abuse them. It depends on what the object is casted as. So, that is the most complex issue and probably the hardest one to do a quick summary on. The analysis, I think, was a little bit could have done a bit more work to make it more clear what was going on there on the type confusion one, in my
Yeah, I
opinion.
feel like I agree on that one. There's also a little bit of just the language being used just kind of assumes you already know everything about. Which,
Yeah.
I mean, I don't necessarily want all the background, but just sometimes when it comes to the acronyms, like even just CID, that could be so many different things. I mean, obviously, if you've worked in this, immediately channel ID. It's pretty obvious, but oh, no, I do agree, though. I felt like it was a little bit rough to read, but on a whole, I did think the analysis, like all three of them, were quite good. I did actually link them out into our Discord um, last night when I was reading them. Just as like, a good exploits kind of look at if you wanted to take a look at something on the Bluetooth stack. I think these could be a good choice to kind of start off with. Maybe not as your depending on how far you want to go, because these don't get you to like the full exploit. But if you want to kind of play around and get a feel for trying to cause at least getting up to that crash and then maybe playing around on your own, these could be fair. Obviously, they don't go all the way to a full exploit, so that does limit who might use these. But I did think on a whole, these analysis entries were quite good.
The question I see a lot is how do I get into exploitation, especially if it's a complex area like kernel or Bluetooth stack in the kernel. How do I get into exploitation? And my favorite response to that is find an NDA or a previous report and just play around with it and try to exploit it. Because I don't think you want to start off with the vuln research right away. I think you want to see what exploit development looks like to kind of augment the vuln research. So these issues seem like they would be good for that kind of recommendation. Getting your feet wet in Linux stuff. I think this is a good area to do that. You have analysis to work from if you need it. Obviously, you have the bugs and POCs to work off of, which is extremely useful because you can, even if you don't want to read the analysis, you can throw the POCs in and run a debugger, although debugging kernel is not fun. But you could play around with it and see what you can do. And you learn the most when you do that kind of stuff. So this might be somewhere to look if you're looking to do that.
Yeah, and I'll just kind of add on, like that is generally kind of once you reach understanding like ROP and kind of this whole we talk about arb write, arb read, like just the general concept of gadgets. Once you reach that point, like there aren't a lot of structured resources to learn from. It is just taking the time to get your feet wet with actual exploits, re-implementing them yourself, going through some of that frustration. Like that's just the general approach to going from all of your educational resources to real world.
The grind.
Yeah.
So regarding the analysis, to be fair, I think there's a blog post coming soon, which probably will be more accessible to people who aren't familiar with the subsystems, and as opposed to the advisories, because the advisories are mostly intended for the Linux kernel maintainers and stuff who are going to be familiar with kernel code. So I think
Fair point.
the blog post is going to probably be more accessible. There was a bit of a mess when it came to the issue being fixed, though. And I saw this initially from Matthew Garrett on Twitter. I'll pull up the tweet on screen here. Um, oh wow, interesting. Okay, maybe the tweet was deleted because it's saying it's not available to me on the logged out Twitter. Anyway, I'll just summarize what the discussion was about. The Intel advisory initially claimed that these issues were fixed in Linux 5.9. They weren't. They were fixed in the Linux Next branch, which isn't a stable release branch. So on top of that, distributions weren't notified about this bug, so they didn't have backported patches ready. So these issues are likely still 0 days, technically, on most systems out there because most people aren't running the Linux Next branch. So it's kind of a screw up by Intel there. They stealth edited it, of course. It now says on the advisory that it affects all kernel versions that support BlueZ. Before it said all kernel versions before 5.9. Because I went to look at the advisory when I saw that tweet, and I was confused because it didn't say what Matthew was saying initially. When I went through the Wayback Machine, I saw they stealth edited it. But come on, really? With the stealth edits, you can't just
I
admit that you
mean,
made a mistake and add a clarification.
Seems like Intel to me, quite honestly.
I mean, it just adds more to the confusion, really. You have people saying that they made this mistake that Intel sweeps under the rug and is like, "Oh no, we never made that mistake." Just
Well, I mean,
adds
look
more
at
to the
how they
mess.
handled Spectre and oh, what's the other one? Meltdown.
Meltdown.
Yeah. Like look at or well even just with like Zombie Load and all those that followed after that too. Like all those issues and how they handled it and had like the NDA for over a year on some of the issues and Intel is just I mean now that we've got the competition from Ryzen on like the CPU front, like I don't know, I've just it feels like Intel's been making a lot of mistakes since that. Just losing respect for them as a company.
Intel makes it really easy to hate on them. They don't give people a lot of reasons to cheer for them. Hopefully, with Ryzen applying pressure, that changes. Maybe that's optimistic though. And
Although,
Intel in general has shown that they don't really have a lot of there's not really a good faith or goodwill towards
yeah,
their
the good
customers.
faith is definitely kind of feels like it's missing. They might not give us a lot to cheer about them, but I mean, on one hand, that does mean we did just provide a 0 day, 4 day zero, so we can keep our little tagline accurate.
Living up to expectations. So we'll jump into our last issue from there. This one is in CHERI BSD, which is an extension of FreeBSD, which includes memory protections, including tagged memory. So
Yeah, if you're not
they
kind of already aware of CHERI, or I'm not sure if it said CHERI or Sherry. I can kind of see it being done either way. It's something I've read plenty about, but I've never actually heard anybody saying it. So don't copy my pronunciation. I'm not sure about yours, Spectre.
I just say CHERI.
Yeah, that's
So
kind of how I've read it, but I'm just not entirely sure about that. But if you're not familiar with it, it's a set. Well, it's a complete ISA that includes several uh, exploit mitigations, basically that quite honestly could be making exploitation fairly difficult. One of them is just the tagged memory, which, as you were just about to get into, in this case, in their BSD version, it does not actually check the tags of the pointers in the shmdt function. And apparently, they also found the same issue previously in munmap. So sounds like that's kind of like a common issue when it comes to these CHERI type systems, is that you've got to remember to keep checking everything, like where it's important. And if you forget to do that somewhere, you're not just automatically protected.
just to be more clear there, the SHMDT is shared memory detach. So shared memory it's an IPC mechanism that's pretty common across especially Unix. I imagine it's probably used in Windows too in some areas. But yeah, so it's a system call basically. And like you were saying there, how they do tagged memory is kind of interesting. It's a little different from what we've seen with memory tagging in other posts we've covered on day zero. They actually use 128-bit extensions of 64-bit pointers, which have protection metadata in those upper 64 bits, and then that tag is checked against the tag table to enforce unforgeability. So one problem that we've seen with memory tagging proposals is the entropy is very limited. They try to keep using 64-bit pointers and just use like a 24-bit bit field for the tag, which is obviously it's a very small entropy. You can brute force that. But here, where it's a 128-bit with a 64-bit tag, that's a more interesting and probably harder to break approach, which I think was pretty cool. I didn't know the specifics of CHERI. I'd heard about it before, but I didn't know they did that.
Yeah,
That
well,
being
do you
said,
remember the Morpheus chip we talked about like way back? I want to say like episode 4. I'm
yeah,
just
I do
guessing about
remember it
that.
vaguely. Yeah,
Yes,
it was
that's
like a
kind
year ago
of
or something.
it was definitely one of our earliest episodes. But that has some inspiration from episode 9. Well, not inspiration from episode 9, but we talked about it on episode 9. But that has some inspiration from the CHERI chips.
Yeah, but the problem with it is, like you were saying there, it seems with memory tagging, it's generally being pushed to be done at a hardware level, right? So whenever you access a pointer, the microcode internally checks, or at least compiler inserted instrumentation checks the pointer. Here, you have to manually insert those checks into the source code. And it kind of has that issue of what you get with like allow lists and block lists, in the way that it's very easy to miss something. And if you do, there's a hole. So that's what happens here, right? They just didn't think to check the tag properly in the shared memory detached system call. So as the last sentence in the report says, if you can increment those pointers without dereferencing them and pass them to the shared memory detached syscall, you can UAF other mappings. So it's funny. The funny thing is, the CHERI maintainer noted that there's more than just this issue in shared memory detach. They noted there were other checks missing as well. So it just seems like this was an area of code that just wasn't really uh, kind of got skipped over, I guess, in the code review process. It is a weird issue. I'm not familiar with CHERI, so I'm not familiar with all the ins and outs of how their tagging system works. I am a bit intrigued though. I kind of want to look at it a bit more, just because, like I said, it's the first time I'm seeing that usage of 64 bits for tags. That is a lot of entropy for tags, where previously we've seen not even 32 bits being used.
Yeah, I mean, Cherry's kind of scary when it comes to the exploit dev stuff.
Yeah. So it's worth looking into, and I think you have a shout out that goes into a security analysis of CHERI as well. So
Yeah,
we'll move
it's
into our
from the
shout outs
same
portion.
author, actually, too. Sorry, I kind of just jumped right in there without you finishing, but
Yeah, no worries. Go ahead.
yeah. So this vulnerability report was from Sar Amar, um, and he's also here on the author of the security analysis of the CHERI ISA. This is just a shout out. We're not going to go over it, but I did find it, and I haven't finished reading over it yet. But I did find like it has a lot of kind of in-depth information that might be useful if somebody wants to take a look at it. So I just want to, leave the link there as a shout out.
All right. We also have another shout out, which is evading defenses using VueJS script gadgets. So we haven't talked much about web in this episode, but this is a web focused article. It talks about like mutation based XSS, which we've touched on before, and like different Vue gadgets you can use to get XSS via the templating language. So they have a cheat sheet put out as well, which is probably something you might want to have in your toolkit if you're doing web app stuff often. But the article does have some interesting behind the scenes information of what goes into those cheat sheet vectors. So that might be of interest to people interested in web app exploitation out there. Z, I know you had two other shoutouts. I'll let you talk about them here.
Yeah, and actually, I'll just add on with the Vue.js one here. Just kind of interested to see some of the gadgets that they found from within Vue.js that you can reuse for cross-site scripting. I mean, it's from Portswigger, so generally speaking, they don't put out bad content. And yeah, I do also have a shout out to the Sega Master System architecture. Not so much on the exploit development side, this is more of an RE thing. I just thought it was a really fun read. I kind of like seeing how some of these old consoles work. So I enjoyed this just as a write-up to look over. And then the last one was a set of CRBUS scripts. So what's interesting here and with this is that this allows for you to extract and modify Intel microcode. So, the code that runs the instructions on your CPU, you can start messing with and looking at. I don't believe you've been able to do that before. Like, I'm not aware of any tools that kind of allow that at like the consumer level. So yeah, I've linked in the GitHub. It's definitely kind of lower level than I do any work at, so I'm not going to comment on how useful that is, but I did find it an interesting release.
Yeah, microcode is starting to get to that more mystical level that most people don't really know too much about, which is why this is also an interesting release.
Yeah, I mean, as far as I know, we haven't really had access to what the microcode running actually was. Like, you can kind of figure some things out based on how it behaves, but you haven't just been able to extract and modify, especially the microcode your CPU is running.
Yeah, I don't think it's really documented, and it's subject to change between like chip to chip. So that's probably why there's just not the support available at that level, because they don't think people should need to mess with anything at that level.
To be fair, you probably don't need to mess with anything at that level. You
No,
can have
more just for
reasons to,
tinkering.
but like few people are going to have um like a business reason, I guess, is more what I'm thinking of.
Unless you want to go hunting for backdoor, instruction sets like Christopher Domus did.
Yeah, no, that would be fair. I mean, I'm sure there are I'm sure we'll see some interesting use cases actually. Um, nothing's really coming to me right now, but I guess I really shouldn't try and limit the creativity and just say no, we don't need this. I'm sure people will do some interesting things with it, or could, if they were aware of this ability.
Yeah. So we'll wrap up the show there. Thank you to everyone who checks out the VOD. Again, apologies for this not being live streamed. We will be back to live streaming next week. You can catch the VODs on YouTube this week. You can also catch them on Twitch when we do the live streams. They go up on YouTube and Spotify, Apple Podcasts, stuff like that at 6 p.m. Eastern, 3 p.m. Pacific on Tuesday. Make sure to join our Discord, follow us on Twitter, and we will be back again next Monday at the same time, 3 p.m. Eastern, 12 p.m. Pacific, or I should say our usual time. And we will see you guys then.